Every satellite orbiting above us, from GPS to weather monitors to the International Space Station, has one thing in common. They are all falling, yes, falling. But here's the mystery. If gravity constantly pulls them down, why don't they crash down? The answer lies in a delicate dance between speed, gravity, and the shape of our planet. When most of us picture a satellite in space, we imagine it floating effortlessly, as if gravity has no power up there. But that's not true. Gravity reaches far into space. In fact, it never really goes away. A satellite in low Earth orbit still feels about 90% of the gravity you feel right now on Earth's surface. It's like being in an elevator with the cable cut. You and the elevator fall together, so you feel weightless. In the 17th century, Isaac Newton imagined an impossible experiment. He pictured a giant cannon on top of a mountain, firing a cannonball horizontally. If you fired it slowly, it would fall and hit the ground nearby. Fire it faster, it would land farther away. But if you could fire it fast enough, the ball would fall toward Earth, but the Earth would curve away beneath it. The ball would never hit the ground. That's what an orbit is: continuous free fall around Earth. The scientific rule is orbital velocity for a circular orbit, like gravitational constant, Earth's mass, and the distance from Earth's center. Like ISS altitude 400 km above Earth, satellite must at least travel 7.8 km per second, and geostationary orbit 35,000 km should travel at least 3 km per second. Different orbit has different stories. Not all satellites orbit the same way. Their passes depend on speed, altitude, and purpose. Low satellite, 200 to 2000 km, they should be fast, and they have 90-minute orbits like ISS Starlink. MEO, about 2000 km, navigation satellites like GPS, and GEO, 35,000 km, moves in synchronous with Earth's rotation. Your TV satellite dish always points at the same spot in the sky. And last, Monelian orbits, highly elliptical, designed by Russian engineers to cover high latitudes where GEO doesn't work. Balance of forces. A satellite's path is a constant tug of war between gravity pulling inward and velocity pushing it sideways. The balance creates a stable orbit. Imagine swinging a ball on a string. The string tension pulls inward, gravity, while the ball's speed keeps it moving in a circle. If you let go, it flies away. If it slows down, it falls inward. But orbits don't last forever. Atmospheric drag slowly pulls down low orbit satellites. Radiation pressure from the sun, the moon's gravity, even Earth's bulge at the equator can shift orbits. Engineers must constantly adjust satellites with tiny thrusters to keep them in the place. So the next time you check your GPS, watch a weather forecast, or admire the night sky, remember, those satellites above us are not floating in the space. They are falling forever, but with just right speed to miss the Earth every time. They don't escape gravity, they live within it, turning free fall into an endless cosmic dance. Don't miss out. New videos drop every Sunday evening. Hit subscribe and ring the bell so you are the first to watch.